In this video, we will learn an easy method to solve the Rubik's Cube. This is the same method that Emily used when she was just 3 years old to solve the cube. We believe this is the easiest method to learn to solve the Rubik's Cube because it focuses primarily on understanding how the cube works and what is necessary to solve it with very little memorization, only a few easy algorithms.
And that's all the hard
Good job, Emmy. What's your time? Ryan, look at the time. It's 2 minutes 59. Wow, Emmy, that's pretty good. To help illustrate the steps, I will use these speed cubes with some stickers removed, which were donated by thecubicle.us. Also this GAN magnetic speed cube, which was donated by GANcubes.com. And then, although just a novelty, this magnetic dice cube, which was donated by magneticcubes.com. First, we need to understand the cube has 6 sides of different colors determined by the centerpieces. For the most part, the colors are standardized, with yellow opposite white, blue opposite green, and orange opposite red. This is important for familiarity and recognition. Bogger, blue, orange, green, red. The edges and corners can be manipulated, but the centers cannot. For demonstration purposes, I will use cubes with the stickers removed. As you can see here, the centers are stationary. Just the edges and the corners move. Here we have a disassembled cube. This is the core with the centers, which, as you can see, they're fixed. So the trick is to put the edges and corner pieces relative to the centers. The centers only have 1 sticker or color. The edges have 2, while the corners have 3. To solve the Rubik's Cube, we are going to use the layer by layer method. For simplicity and familiarity, we will make yellow the top, which will make the bottom white. First, we will solve the first layer, the bottom layer, in 2 steps. First, we form a white cross, then we insert the corner pieces. So it's important to notice this isn't just one side or face solved, but the entire face and the sides matching their corresponding centers, which is important. Here we have the white face solved, but the sides don't match the corresponding centers. All of these should match green, all of these should match orange, blue, red. Next, we solve the second layer, the middle layer, which is really just inserting 4 edges because the centers are stationary. Then we solve the last layer, the top layer, in 4 steps. First, we get a yellow cross on top. Then all the yellows facing up on the top. Then we orient them by fixing first the corners, then the edges, which solves the whole cube. Before we begin, we need to learn some terminology and notation. Each of the 6 sides has a name. Whichever side is facing you is the front, with all other sides relative to it. So from here we have the right, left, back. The top is called up and the bottom is called down. Clockwise and counterclockwise turns are always as if facing the side being turned. Counterclockwise is called prime or inverted. So from here we would have a right, right prime, left, left prime, front, front prime, up, up prime, down, down prime, And don't get tricked by the back. It's as if facing. So back, back prime. Counterclockwise can be represented in notation with an apostrophe or a lowercase I. 2 means turn that side twice. So 2R would be 2 turns, whether it be clockwise or counterclockwise. It doesn't matter. It's a 180-degree turn. So F2 and L2. In notation, each turn is designated by the letter. So capital R is right clockwise. R apostrophe is right prime. Capital L, L clockwise, L apostrophe equals L prime. A lowercase letter means we turn the side and the center with it. So a lowercase r would be the right side and the center a turn clockwise. Lowercase r prime would be a turn counterclockwise. Lowercase l prime, lowercase f prime. Now we have axis rotations of the entire cube. And X means you turn the cube so that the bottom is now the front and facing you. X prime means you turn it the opposite way. A Y rotation turns the right side towards you and it now becomes the front. A Y prime turns the left side towards you and it now becomes the front. Don't get too hung up on this notation though, as much of what we will do is visual and intuitive with very little memorization. We must first form a white cross on the bottom by placing the 4 white edge pieces in the bottom layer with the adjacent colors matching their centers. The beginner method to do this is to place all the white edge pieces on the top with the yellow center sticker. This may take 1 move or 2. Make sure not to knock out one of the edges that you've already put in when you insert a new one. Just turn the top up layer if need be. Now we turn the up layer to orient the edges one at a time so the adjacent color matches its center. Then we spin it down with an R2, slap the side. And we have a solved white cross. All the edges are correct with their respective center colors. Let's perform that on this cube. That one's solved white cross. Once we have the white cross on the bottom, we only need 4 corners to finish the first layer, the bottom layer. To do this, we find a corner on top with a white sticker facing to the side, not facing up. Then we place it above its intended location. This is orange-blue, so it goes above the corner between orange and blue. A quick shortcut to do this is notice the side color and then just match it up with its center color. So wrong, wrong, correct. Do the same with this. Just look at this blue, and a quick shortcut is just when it touches that blue, you're good. That's the intended location. Let's do it with this one, green. And then that's where that one goes. Okay, let's go back to our orange-blue. We want to insert this corner piece without knocking out our edge piece. An easy way to do that is if the white sticker's on the right side in this example, you slap the white and perform right, up, right prime. If it's on the left side, slap the white, left prime, up prime, left. The slapping the white side was just a memory trick Emily used to use when she was 3. If we do the wrong way, it's pretty obvious and easy to fix. So now we have all the corner pieces in the correct locations. So basically your corner pieces have to match these centers. If the white corner sticker is facing up, you can't insert it that same way. What you want to do is just bring that white sticker down any number of ways. You can do it right, up, up, right prime, and then just insert it like you normally would. Or from the other side. If a white corner is on the bottom but in the incorrect location, just kick it out any way you like. Move it to the right spot and insert like you normally would. If it's in the correct spot, just orient it incorrectly, kick it out. Again, kick it out any way you like, but try not to kick it out with the white sticker facing up. That'll save you a few steps. Remember, don't get hung up on notations and following directions. Just think about what you're trying to do and find a way to do it logically. In order to solve the second layer, we need to locate and place the 4 edge pieces relative to their corresponding centers. First, we look on the top layer for an edge piece with no yellows. Yellow is a top layer color, so no middle layer edge can have a yellow. Once you find an edge with no yellow, notice the color on the side, not the top, and spin the top until it matches its center color. Notice its intended location. We want to get it here without disturbing the first layer. What we're going to do is take the corner out, pair it up with this edge, and reinsert them both together like this. I'm going to go ahead and use the demo cube now. We've got the same orange blue, and we're going to pair it up with this corner. One simple way to do that is notice the color on top and then find its center. Turn the top layer, the up layer, one turn away from its center. So again, the blue, blue, one turn away. Now take the corner piece beneath where that edge piece goes and move it up towards the edge piece. Chase it. Right, up, right prime. Now move that corner back over its empty spot where it goes. So here we have the edge, here we have the corner. Now just insert this corner piece as you normally would. Slap the white side. And you can see it paired up with that edge. Okay, so again, we just look at the top piece, move it away from that center, take the corner, chase it, move the corner back, and then just insert like we normally would. We call this sequence Special Rabbit because you kick out the corner, chase the edge, but the edge ran away because it's a special rabbit. So we go back to the starting point. How do you catch a special rabbit? You sneak up on it, pairing the edge and corner before reinserting both. It's important to notice as we solve the corner, it's connecting with the edge before reinserting. Make sure you actually see and understand this and just don't follow a set of instructions. If an edge is already in the second layer but in the wrong location, just kick it out and then reinsert the corner. Now that edge is out, line it up, orange away from orange. So let's look at this on this cube. green away from green, kick the corner towards it, put the corner back in the starting spot, connect them, reinsert. And for the last one, red away from red. And that's all of them. If you have one in backwards, same thing, just kick it out any way you like, solve the corner, and then just solve it as you normally would. Again, it's not important to memorize the turns, but rather understand the principle of connecting corners and edges before reinserting. Try to understand what we are doing in this step. We are catching special rabbits. Now for the last layer, we will learn some shortcut sequences called algorithms. The more you know, the faster you will be able to solve the cube. But to start with, we are only going to use a few. We go over more in part 2. The algorithms that we're going to use won't disturb the first 2 layers that we've already formed. The first step to solving the last layer is to place the 4 yellow edges on top, forming a yellow cross. To do this, we perform one easy algorithm 1 to 3 times, depending on the situation. If we have 2 yellow edges on the top forming a line, we hold the line horizontal and perform the algorithm once. Front, right, up, right prime, up prime, front prime. Now we have a yellow cross. Disregard any corner pieces. We're only looking at the edge pieces. So this is a line just as this is. There we have the cross. Again, disregard corner pieces. We're just looking at these right now. If we have 2 yellows perpendicular to each other, we hold them in the 12 o'clock, 9 o'clock position and perform the algorithm twice. Once creates the line, and then again creates the yellow cross. Again, disregard any corner pieces. We're just looking at the edges now. Clock hands may be a difficult concept for children if you only have digital clocks in the house. At 3 years old, Emily only knew this orientation and had no idea what 12 o'clock, 9 o'clock meant. Now we must orient all the corner pieces so the yellow sticker is on top facing up. This is called Orient Last Layer, or OLL. Once you have the yellow cross, there can only be 7 possible arrangements, each with its own algorithm to get all the yellows on top. We are only going to learn 2 though, one forward and backward and one other easy one, a variation of the yellow cross algorithm. First we start with the fish patterns, which get their name because someone thought this looked like a fish. I don't see it. Notice that although these 2 patterns look the same from the top, they are different because of the way the yellow stickers are oriented on the sides. My children called this one Little Fish and this one Big Fish for no other reason than they like the song Down by the Water by PJ Harvey. To solve Little Fish, we hold the cube so that this corner is on the left side, and then on the right we have a yellow sticker facing us. To solve, we perform the Little Fish algorithm. Right, up, right prime, up, right, up, right prime, which gets all the yellow corners on the top. Again, that's right, up, right prime, up, right, up, right prime. If there's no sticker right here facing you, then you have big fish, and you have to hold it like this. So for example, these two look the same, but they're different. Now for the pattern we call big fish. To solve this, we hold it so that the up facing yellow is on the back right corner, and then the yellow facing towards us is on the front left. And we perform the inverse of little fish algorithm, which is right, up prime, right prime, up prime, right, up prime, right prime. Once you know an algorithm well, it becomes intuitive to perform it forward and backwards. And one quick practice trick is if you have this solved and you perform little fish, right, up, right prime, up, right prime, it actually makes big fish. So you just do the inverse. If you do big fish, it makes little fish. So that's a quick way to practice. Now we have big fish. Perform big fish again. We have little fish. Perform little again. You have big fish. So it becomes pretty easy. Now we look at two crosses with no yellow corners on top. The first of which we call double fish has two yellows on the left and two yellows on the right. The second, which we call no fish, has two yellows on the left, but then a yellow facing us and then a yellow to the back. To solve double fish, place the yellow corners on the left and the right sides and perform little fish twice, hence the name double fish. Of course, you could perform big fish twice, whichever you prefer. Now, as you will see, performing this algorithm twice, we do a few unnecessary moves. Namely this right prime, right. But as a beginner, it's best just to do them fully at first. We call this one no fish because we don't use any of the fish algorithms. So to solve no fish, place the two yellow corners that are on the same side to the left and perform a slight variation of the yellow cross algorithm. Instead of front, right, up, right prime, up prime, front prime, we perform lowercase f, which is double front, right, up, right prime, up prime, lowercase f, prime. Then we do our standard front, right, up, right prime, up prime, front prime. So again, we're going to use a variation of our yellow cross algorithm. Double front, right, up, right prime, up prime, double front prime. Front, right, up, right prime. That's pretty easy to memorize because it's basically the same exact algorithm. You just have to learn when to apply it. It's pretty easy to practice because you just do the same exact move to set it up. You just have to turn the top 180 degrees. So if we get one of the three patterns that we don't know, just perform little fish until you get one that you do know. So this one just became double fish. This one just became big fish. And sometimes when you perform little fish, you still don't have one you know, just do it again. And this one became no fish. This allows us to solve 4 of the 7 possible OLL arrangements for the yellow cross with only 2 algorithms, one of which we already learned and used. We now have our first 2 layers complete and all the yellows on top. We just need to position the top correctly relative to the centers. First we'll fix the corners and then the edges, which will solve the entire cube. A quick and simple shortcut to correct the corners is to find a side that has 2 corners the same color. Place these to the back. Place these to the back and perform an axis rotation X. Then the algorithm right prime, up, right prime, down, down, right, up prime, down, down, right, right. At this point, all your corners will be fixed. Okay, so one more time a little quicker. Find 2 corners the same. You can line them up with the correct color or not. It doesn't matter. Just put them to the back. X. And now they're all fixed. So if I want to practice it, just do it again. Find the 2, put them to the back. So you can either turn the whole cube or just flick them to the back. And I got a lucky skip there. That wasn't supposed to happen with the edges. If no side has 2 corners the same, just perform the algorithm once. Then it will have 2 corners the same. Find them, place them to the back, and do it again. Okay, no corners the same. Those are, put them to the back. And again, I got a lucky skip. Sometimes you get lucky and don't have to solve a particular step. In this case, the edges solved. So now this algorithm looks and sounds more difficult than it really is. It becomes muscle memory, plus you're combining several turns into one. So for example, that's one move, even though that's 1, 2, 3 distinct moves. That's pretty much one move. 2, 3, 4, 5. I mean, technically that's not 5, but that's pretty much what my brain recognizes it as 5 steps. Now we turn the top so that the corners match. And then at that point, we just have to fix the edges. We are looking for 3 edges out of place, not 4, as in this case. We'll go over this in a little bit. When we have 3 out of place, we put the solved side to the back, and then we look to see if this edge on the left is supposed to go to the right. If it does, as Emily would say, this one goes here, I do it once. We perform the algorithm just once. This algorithm is muscle memory, so it's actually hard for me to do slow. I just do it without even thinking about the turns, but I'll try to do it slow. So right, up, right, up. Right prime, up prime, right prime, up prime, right prime, up, right prime. Now, if the solved side's on the back and this edge piece does not go to the right, we have to do it twice. So, and then now this piece does go there. Again, this is another one of those where you combine moves and it doesn't seem like as many turns. So, for example, this last step is 1, 2, 3 turns, but you really just do it as one. Okay, here's another example of all 4 edges wrong, but wrong differently. Last time these 2 needed to trade. This time they need to trade diagonally. So let's perform the algorithm once. And at this point we have a solved side. Then we put it to the back. We see, does this go here? No. So in this case we'll have to do it 2 more times for a total of 3. The entire cube is now solved, or as Emily would say,
Man, I'm already done.
while this may seem difficult at first, with a little practice it becomes quite easy. We learned the principle by which we plan to solve the cube, and we only had to memorize a few easy algorithms. The rest is just practice and patience.